Hello everyone, my name is Yash Kumar. I am a third year PhD here at LCS2 IIITD. Today I will be discussing my recently published paper at Knowledge Based System titled See Hear Read Leveraging Multimodality with Guided Attention for Abstractive Text Summarization. So the motivation behind the problem is that with the advancements in the multimedia technology and the recent COVID outbreak, the rise in the multimodal data has risen exponentially. And we as humans are unable to go through all the data in multimodal form. So a need of a system which can quickly decipher the gist of a multimodal content is highly essential. However, the current literature fails to provide us with a dataset and a system that can accumulate videos of varied lengths and provide a coherent summary. So now coming on to the problem statement, our aim is to generate an abstractive textual summary by leveraging all the modalities, that is videos, audios, and text. For the dataset part, we propose a new dataset called AVIATE, which consists of academic conference videos accompanied with the academic paper. The dataset is compiled from 28 academic conferences in computer science and social sciences, spanning over various domains such as machine learning, deep learning, data mining, computer vision, etc. And most of the videos of our dataset comes from conferences like NDSS, ACL, NACL, CPR, etc. Unlike other datasets, we do not annotate the summaries ourselves, which significantly improve the quality of the ground truth summaries. The videos and the slides accompanying serves as our input, and the abstract of the same paper serves as our target summary. Now going over to the dataset, we can say we have basically partitioned the dataset into three classes. The one is short, which basically houses all the videos that are less than 10 minutes of length. Second is medium, which contains videos between 10 minutes and 30 minutes. So the third is long videos, which are basically videos spanning over 30 minutes. As you can see, for short, we have around 2000 videos. For medium, we have approximately 5600, and for long, we have approximately 400 videos. Coming on to the source percentage statistics across the dataset, we can see that majority of the dataset is basically compiled from ACL, ICML, CVPR, NeurIPS, etc. Now for the plots and to see the correlation of video and target summaries, we can see the correlation factor between the number of words and reference summaries versus the percentage of videos. In the second graph, we can see the video lengths in minutes versus the number of words and reference. In the third, we can see the number of words and reference summary versus the percentage of videos. And the final graph, we can see the video length in minutes versus the number of words and references. Now, coming on to our proposed model titled FLORAL, we are basically taking three different inputs of modalities. The first is the ResNext 152 video features, which we term as. So here we take a video, we partition it into frames, and then for each frame we extract the video features from this particular model, ResNext 152, from which we get a 2048 dimension embedding. Right now, for the audio part, we basically extract the mal frequency coefficient, and we get a 512 embedding. Now, for the transcript part, we are basically taking two forms of features. The one is ASR, the second is OCR. ASR is the speech recognition, so we basically uses the Mozilla's deep speech model to generate the transcript of the videos, and from the slides that are accompanying a particular conference video, we extract the features using an OCR model. Now we club both the ASR and OCR using a guided attention, and finally we get a 768 feature embedding. We pass all these three features into a FMT model where we basically predict a single token. So this is a decoder-only language model, and the task of language model here is to just predict a single word, single token based on the input that it has received. Now for the input part, what we are doing here is we basically takes all these three modalities embeddings, and we concatenate the tokens that has been generated by this FMT architecture, right? So if at time step t it has generated a certain token, now at t+1 it will generate a next token, but the token that has been generated at t will be concatenated into the features that we have already generated, right? Now coming on to the guided attention part, we can see we take the ASR, we take the OCR, we use this guided attention network, and then we extract the fused output. Now for the results part, we here provide benchmarks over certain extractive baselines, abstractive baselines, and abstractive multimodal baselines. Now for the extractive baselines, we are benchmarking KL, some Lexrank and TextRank, which are basically graph-based approaches, for which we see that the ROUGE-1 score is between 24.27 24.55. Now for the pointer generator part and its extension, the ROUGE-1 holds at 27 to 28, and for the transform it is at 30. We also benchmark our proposed data set over multimodal baselines. So this is the multimodal hierarchical attention network where we get a ROUGE-1 of 28.14. We also benchmark for the language model and the encoder-decoder architectures. So, and finally we benchmark the FLORAL with OCR and without OCR. So here we can see that if we remove that OCR section from our feature pool, you see that the ROUGE-1 performance here we are getting is 33.26, which is basically similar to the multi-LM, which is giving 33.47. But when we fuse this OCR feature, we get 37.13, which is a drastic improvement. Now for the evaluation part, where we see the significance of multimodal queues, we see that when we fuse all the three modalities, we get the best performance, and each individual modalities basically contributes to it. Now coming on to the conclusion here is we basically propose a new data set called AVIATE. We propose a new factorized multimodal transformer-based decoder-only language model. We showed it how guided attention incorporating OCR and ASR helps in this particular model, and we showed that how the automatic metrics and the manual evaluations done by humans shows that the proposed model basically outperforms all the other baselines. So that is it. Thanks a lot, guys. If you have any doubts, you can reach out to me at yash@iit.ac.in.